Hello friend, welcome to the Pure Mathematics YouTube channel. Math for beginners, arithmetic. It is class 8. Title Finding LCM by using prime factorization. It is our title. Last lesson we studied about definition of LCM and how to find the LCM of numbers by using common multiples. So here we want to explain this method how we can find LCM by using prime factorization. Finding LCM by using prime factorization. First, we change the given number First, we change the given numbers into their prime factors. Then those numbers, those prime factors those prime factors which are present in all product of prime numbers product of prime factors then those prime factors which are present in all product of prime factors and those numbers, those prime factors which are not present we multiply together then the product of them is LCM. It is the method. Now we want to solve the question. Question 1. Example. Find the product of find the LCM of the following numbers. Question 1. LCM 36, 60. Number 2. LCM 180, 150. Number 3. LCM 30, 25. Number 4. LCM 120, 90, 160. We want to find the LCM of these numbers. First one, as we explained already. First question, LCM of 36 and 60 is equal to a question mark. First, we want to find the prime factor of 36 and 60 separately. When we when we want to find the prime factor of 36, then here we divide 36 by 2. 33 divided by 2, 1. The result is here we have 1 by with 6. It will become 16. 16 divided by 2, 8. Again by 2, 18 divided by 2, it is 9. Now it is divisible by 3. 9 divided by 3, 3 divided by 3, 1. Actually 36 is equal to how many 2 we have? 2 to power 2, 3 to power 2. 60, we want to change 60 into its prime factors. Divided by 2, 60 divided by 2, 3, 0. Divided by 2, 1. 3 divided by 2, the quotient is 1, and we have remainder 1 with 0. It will become 10. 10 divided by 5, it will become 5. It is divisible by 3. 15 divided by 3, 5. It is divisible by 5. 5 divided by 5, it is 1. Now 60 is equal to 2 power 2 into 3 power 1 into 5 power 1. Now we want to choose LCM of 36, 60 is equal to, here those numbers which they have same, we have 2, also we have 2. From both of them which they are same, we choose one of them. 2 power 2 into, we have here we have 3 to power 2, but here we have 3 to power 1. Which one is that the exponent of which one is greater? Obviously here 2 is greater than 1, so we choose 3 to power 2. 3 to power 2 into, here we have 5 to power 1, we don't have 5. Also it is different from others, so it's not present in prime factors of 36, so we want to take 51. It is equal to 2 power 2, 4 into 3 power 2, 9 into 5. It is equal to 4 into 9, 36. 36 by into 5. It is equal to 5 multiplied by 6 and 30, 0. We have 3. 5 multiplied by 3, 15. 15 plus 3, 18. 180 is the least common multiple of 36 and 60. Number 2, we have 180, 150. Both of them we want to change both of them in prime factors and their prime factors. So first one, LCM 180, 150. 180 divided by 180 divided by 2. 18 divided by 2, 9, 0. 9 divided by 90 divided by 2, 9 divided by 2, 4. Remaining we have remaining 1 with 0. It is 10. 10 divided by 5 by 2, the result is 5. It is divisible by 3. 1 into 3. 3 we have 1 with 5, it's 15. 15 divided by 3, 5. again by it is divisible by 3. 15 divided by 3, 5. 5 divided by 5, it is 1. Quotient will be 1. 180 is equal to 2 power 2 into 3 power 2 into 5 power 1. Next one, 150. 150, we want to decompose 150 into its prime factors by 2. 15 divided by 2, 7. 1 here, 10 divided by 2, 5. It is divisible by 3. 7 divided by 3, 2. We have a remainder 1 with 5. 15 divided by 3, 5. 5 divided by 25 divided by 5, 5 divided by 5. Result 150 is equal to 2 power 1 into 3 power 1 into 5 power 2. We have 1, 2 and 1, 3 and 2 times we have 5. So now we want to write the LCM of 180, 150 is equal to, here we have 2 to power 1, 2 to power 2, and here we have 2 power 1. We choose this one because it is greater than 2 power 1. So 2 power 2 into, here we have 2 power 2 and here we have 2 power 1. So we choose 2 power 2 into, here we have 5 power 1, here we have 5 to power 2, 5 to power 2. It is equal to 4, 9. It will become 25. 5 square is equal to 25. It is equal to 4 into, if we multiply 4 by 25, it is 9 into 100. It is equal to 9 into 100, 900. It will be easy to find. 900. It is the LCM of 180 and 150. These are question 3 and 4. We want to solve this question by another method. In the same time, we want to decompose 30 and 25. So number 3, we write 30 and 25. 30 divisible by 2. 30 divided by 2, 15. 25 we take down. It is 3 divisible by 15 divisible by 3. So 15 divided by 3, 5. 25. Here 5. 5 divided by 5, 1. 25 divided by 5, 5. 5. 1. 5 divided by 5, 1. So then it implies LCM of 30, 25 is equal to, we multiply these numbers on the left side of this vertical line, 2 into 3 into 5 into 5 is equal to 2 into 3, 6 into 5 into 5, 25. It is equal to 6 multiplied by 25, 6 multiplied by 5, 30. We have 3, 6 divided multiplied by 2, 12. 12 plus 3, 150 is the LCM of 30 and 25. Number 4, we have 120, 900, 160. We consider this number. All of them are divisible by 2. 12 divided by 2, 6, 0. 90 divided by 2, 45. 16 divided by 2, 8, 0. Also divided by 2, 30. 60 divided by 2, 30. 45 is not divisible. 40 by 2, 100, it is 15. 45, 20. Again divisible by 2, 15. 45, 10. Also here we have 10 divisible by 2, 15. 45, 5. Now here they are divisible by 3, 15 and 45. By 3, 5, 15, 5. Also divisible by 3 because of this 15. 5, 5, 5. All of them are divisible by 5. Our finding prime factorization is over. LCM 120, 90, 160 is equal to, here we multiply all of them, it is equal to 2, 1, 2, 3, 4, 5, 2, 2, 3 into 3 into 5. It is equal to, when we multiply this number, it will become 32. 3 by 3, 9, 5. It is equal to 9 multiplied by 2, 18. 9 multiplied by 3, 72. 72 plus 1, 78 into 5. It is equal to 5 times 8 is 40. 40 0. We have 4. 4 is the 10 plus 5 multiplied by 5, 40. 40 plus 4, 44. 44. We have 4. 5 multiplied by 2, 10. 10 plus 4, 14. 1440 is LCM of 120, 90, 160.